What if I told you there are helicopters out there so over-engineered, so absurdly redundant, that losing an engine, losing a tail, even losing the ability to lubricate their own gearbox doesn't bring them down? While most people think helicopters are basically flying death traps held together by physics and prayers, there are machines out there that were built to laugh at mechanical failure. Today, we're looking at the helicopters that aeronautical engineers designed to survive almost anything. And some of these features are going to blow your mind. Stick around. Before we dive in, let's set the stage. Because to understand why these helicopters are so special, you need to understand why most helicopters are so vulnerable. The biggest weakness of any helicopter is the lack of redundancy. An airplane can lose an engine and keep flying. But in a traditional helicopter, the main rotor, the gearbox, and the tail rotor are all single points of failure. Lose any one of them, and you're in serious trouble. That's the baseline. That's what engineers have been fighting against for decades, and some of them came up with insane solutions. First up, the AgustaWestland AW101 Merlin. This thing doesn't have two engines. It has 3 turboshaft engines on a single helicopter. That means if one engine goes out, you've still got 2 left carrying the load. If 2 go out, you still have 1. That triple engine setup was specifically designed for overwater and mountain operations, where losing power means losing everything. But here's what makes it truly special. The AW101's transmission can run for 30 minutes with no lubrication. That's right. The gearbox can run completely dry for half an hour. In any other helicopter, a loss of gearbox oil means catastrophic failure in minutes. The Merlin just keeps flying. Add to that a dual-duplex flight control system with 2 computers providing redundancy and fault tolerance, a 20G crashworthy structure, and obstacle and terrain avoidance warning systems, and you've got one of the most overbuilt helicopters ever made. Several nations trust this machine to carry their heads of state. That tells you something. Now let's talk about a helicopter that eliminated one of the most dangerous failure points entirely, the tail rotor. The Boeing CH-47 Chinook doesn't have one. Instead, it uses 2 massive counter-rotating rotors, one at the front and one at the back. They spin in opposite directions, cancelling out each other's torque. No tail rotor means no tail rotor failure. That vulnerability simply doesn't exist, and it gets better. Both rotors are driven by the same pair of engines, but if one engine fails, the other can power both rotors by itself. The Chinook has been in continuous service since 1962, over 60 years, and it keeps getting upgraded. The CH-47F model brought improved redundant electrical systems, an advanced flight control system, and composite rotor blades. The tandem rotor design also gives pilots exceptional stability, even in high winds and thin mountain air. The pilot can independently adjust the pitch on each rotor to keep the aircraft steady in conditions that would overwhelm a conventional helicopter. There's a reason armies around the world still rely on this design. It works, it survives, and after 6 decades of continuous production and upgrades, the Chinook remains one of the most trusted heavy-lift platforms on the planet. If you're enjoying this deep dive into helicopter engineering, hit that like button and subscribe so you don't miss the next one. Trust me, we've got more to talk about. Now here's something that sounds like it came straight out of a movie. The Kamov Ka-52 Alligator is the only operational helicopter in the world with ejection seats. Yes, ejection seats. In a helicopter. The problem, obviously, is the rotor blades spinning above the cockpit. So how did Russian engineers solve that? Explosive bolts. When a pilot triggers the ejection system, explosive charges blow the rotor blades clean off the aircraft. The canopy is jettisoned, and then rocket-powered seats fire the crew upward to safety, just like in a fighter jet. The Ka-50, its predecessor, was the first helicopter ever designed with this system, entering service in 1995. But the Ka-52 took it further with side-by-side seating and dual controls. meaning either pilot can fully control the aircraft if the other is incapacitated. And then there's the coaxial rotor system. Like the Chinook, the K-52 has no tail rotor. Two rotors stacked on the same shaft spin in opposite directions. This means the entire tail section could be destroyed, and the helicopter can still maintain flight. In conventional helicopters, losing the tail rotor is almost always fatal. In the K-52, it's survivable. Have you ever heard of a helicopter with ejection seats before? Let me know in the comments. Next up, the Sikorsky UH-60 Black Hawk. This helicopter was born from the lessons of Vietnam. The US Army watched the UH-1 Huey take devastating losses. Single engine, minimal armor, limited crashworthiness. So when they designed the Black Hawk, they essentially said, never again. The result was a helicopter built around the concept of surviving what it couldn't avoid. The landing gear can absorb a vertical impact speed of 38 feet per second. The crew seats are energy absorbing, designed to compress in a controlled way during a crash, protecting the spine from lethal G-forces. The fuel tanks are self-sealing and crash-resistant, specifically engineered to prevent post-crash fires, which were historically one of the deadliest threats to downed crews. The flight controls are redundant. The hydraulics are redundant. The electrical systems are redundant. Even the main and tail rotor blades are built from ballistically tolerant materials, meaning they can take hits from small arms fire and keep spinning. The Black Hawk doesn't just try to prevent failure. It's designed to make failure survivable. It was one of the first military helicopters engineered from the ground up with crashworthiness as a core requirement, not an afterthought. That philosophy changed the entire industry. And finally, the newest beast in the lineup, the Sikorsky CH-53K King Stallion. This is the most powerful helicopter in the US military, and it might also be the most technologically advanced helicopter flying today. It runs on 3 General Electric T408 engines, each producing 7,500 shaft horsepower. Each engine is monitored by dual redundant digital engine control computers. But the real game changer is the flight control system. The CH-53K is the first in the CH-53 family with absolutely no mechanical flight controls. Everything is fly-by-wire. And that system is triply redundant. 3 separate flight control computers running in parallel. If one fails, the other 2 keep the aircraft perfectly stable. If 2 fail, the remaining one still has full authority. The system even has position hold and height hold modes that keep the aircraft locked in place during brownout conditions when pilots can't see the ground. A Marine Corps test pilot with 25 years of experience has called the King Stallion's handling qualities unmatched by any other helicopter he's flown. The aircraft also features a health and usage monitoring system that constantly tracks the condition of critical components, detecting problems before they become failures. It doesn't just survive emergencies, it prevents them. What makes all these helicopters special isn't just one feature, it's the philosophy behind them. Every single one was designed by engineers who asked the same question: what if something breaks? And then they designed around the worst-case scenario. Triple engines, dual redundant controls, crashworthy structures, ejection seats, dry-run transmissions. These aren't just machines, they're survival systems with rotors attached. So which one impressed you the most? The 3-engined Merlin that keeps flying without oil, the Chinook that ditched the tail rotor entirely, the K-52 that lets you eject? Drop your answer in the comments. And if this video surprised you, leave a like, subscribe, and hit the notification bell so you catch every video we put out. See you in the next one.